Alright, quadratic formula part 2. Quadratic formula right here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you're going to get that a, b, and c from standard quadratic form. In this case, a is 1, b is negative 6, and c is negative 5. And we're just going to plug in. Now recall we left off with this problem. We tried to solve it by factoring, and it is not factorable, so we weren't going to find any rational roots. But we can find real roots or even imaginary roots by using the quadratic formula. Alright, a is 1, b is negative 6, c is negative 5. So negative b, or the opposite of b, is going to be negative 6, or 6. Then inside the radical, negative 6 squared is 36. If you're using your calculator for that, use your head too. Negative times a negative is a positive. Negative 4 times 1 times negative 5. Now I'm going to think about this first. But let's move on. Divided by 2 times 1, so divided by 2. Okay, so why am I thinking about that? Because I want to know whether these, whether I'm going to be adding or subtracting, first of all, inside the radical, and then after that, like, is it going to be an imaginary number or not? In this case, definitely not, because I have a negative times a negative is a positive. Well, did you see a negative times a negative? Well, let's see, 4ac, a positive and a negative. No, where's that other negative? Well, it's right here. Subtracting is like negative, right? It's like negative 4 times a times c, and that's what I'm going to think of. Negative 4 times negative 5 is 20, positive 20, so I'm going to be adding 36 and 20 together. Bring down the rest. 36 plus 20, 56. So I have 6 plus or minus the square root of 56 over 2. Now are problems that look like this, where we just simplify. All right, 56. Let's see if we can do anything with 56. Are there any perfect squares in there? Let's see. We've got 2 and 28. Let's see. 28 is a composite number. How about 4 and 7? 7 is prime. 4 is a perfect square, but I'd rather go down to the prime factorization if you don't mind. 2 times 2 times 2 times 7. So I'm going to do the pairs is squares, or pairs come out. So I'm going to get a 2 coming out of the radical, a 2 and a 7 staying in the radical, and they're going to multiply each other. So 2 radical 14. Bring over the rest. Now this 2 divides both that 6 and that 2, and I'm going to get 3 plus or minus the square root of 14. 3 plus or minus the square root of 14. You are not going to find that by factoring, but by the quadratic formula you can. So here's the deal. If you can look at a quadratic and think to yourself, does it factor, and fairly easily work out whether it does or doesn't. If it does, solve it by factoring. If it doesn't, then use the quadratic formula. Or if the numbers just look too outrageous and you don't want to think of a bunch of factor pairs of a very large number, then maybe you want to jump to the quadratic formula. Okay, the discriminant. Inside the radical is your b squared minus 4ac. Remember I said I wanted to start with the 4ac? Well, the b squared minus 4ac is called the discriminant. So this thing right here is called the discriminant. What type of number you get from that tells you what type of solutions you're going to get and how many. Alright, so recognize this one from the beginning. We solved this one by factoring, but let's take a look at what we would see if we started to solve it by using a quadratic formula. A is 1 and c is 0. So if I do 4 times 1 times 0, that's going to be 0. So the discriminant is going to turn out to be 3 squared is 9 minus 0, which is 9. So the discriminant was 9. 9 was a perfect square. And if you get a perfect square, that means that you are going to get rational roots. And you're going to get 2 of them. You're going to get 2 of them because, let's see, the rest of it was going to be negative b, which was negative 3, plus or minus the square root of 9, which was 3, and it was all over 2a, so it was all over 2. So I ended up getting 0. So one of our roots was 0. Negative 3 plus 3 is 0 divided by 2. We got 0. And the other one was negative 3 minus 3 is negative 6 over 2, negative 3. So our 2 answers were 0 and negative 3. 2 rational roots. So if the discriminant is a perfect square, you get 2 rational roots. Let's take a look at the one in the middle here. B squared is 100 minus 4 times 1. Now let's not even write times 1. Let's just move to the C. Times 25. Okay. 4 times 25 is 100. I get 100 minus 100. So the discriminant this time is 0. The square root of 0 is 0. Since I get 0, I get 1 rational root. Why is that? Well, that's because I will be adding 0, square root of 0 is 0. I'll be adding 0 one time. I'll be subtracting 0 another. There's no difference. So let's take a look at the rest. Negative b is going to be positive 10, and then it's going to be plus or minus 0, and then all over 2a. So that's all over 2. So 10 plus 0 is 10. 10 minus 0 is still 10. Both of those divided by 2 give you 5. So one answer, it's 1 root, 1 rational root. All right, this one here, b squared is going to be a positive 9 minus 4 times a is 2, c is 15. What's going to happen here is I'm going to get a negative number inside the radical because 4 times 15 times 2 is larger than 9. So I'm going to get 9 minus 120, and that's going to be 111. And that is not a perfect square. It doesn't really matter. If it was, we would still get 2 imaginary numbers. So I'm going to get I radical 111. And the rest of it was going to be negative b would be a positive 3 plus or minus I radical 11 all over 2a, so that's all over 4. All right, so the number inside, when it was negative, gave me 2 imaginary roots. There's one more that isn't covered here. If I got a number that wasn't negative, but it was like the number 111, then I would get something that was positive but not a perfect square. In that case, I would get 2 roots, but they would be real. So let's see. If the discriminant is positive and also not a perfect square, I get 2 roots, but they're not rational. They're not fractions or whole numbers. I get they're real. 2 real roots. So those are all my options. If it's a perfect square, 2 rational roots, that meant it factored. If I had 0, 1 rational root, also would have factored. If I got a negative number, 2 imaginary roots, you'd have to use the quadratic formula for that. It wouldn't factor. If it was positive but not a perfect square, 2 real roots, and you would have had to have factored that one. I'm sorry, you wouldn't have had to factor that one. You would have had to use the quadratic formula for that. Okay, so we end with a couple of examples. We'll do the first one together, and then you try the second one. I could try to go ahead and factor, but I'm just going to skip to the discriminant. If I find the discriminant is a perfect square, I could back up and factor it from there. I'm not going to do that though. All right, b squared is 196 minus 4 times 3 times 10. I've got 12 times 10, 120. 196 minus 120. Okay, that's a positive number, so at least I know it's not imaginary. What do we get here? 76. That is not a perfect square, so I am going to get 2 roots, and they will be real, not rational. But let's just continue with this. 76. Let's see. 2 and it goes 38 times. 2 more and 17. So out comes a 2. In stays a radical 17. So all of this was in a radical. It's still in a radical. It's still in a radical. Part of that 76 comes out. The pair is a square. It comes out of the radical. The 17 is doesn't have a pair in its prime. It stays in. The rest. Negative b is going to be positive 14 all over 2a, so that's all over 6, and I've got the plus or minus. It was a good idea to use the quadratic formula on this one. By the time I got to that 76, I knew it was the only route. So let's see. Simplify both of those by dividing by 2, and I get 7/3 plus or minus 1/3 radical 17. So I could just write it like this. Okay, you take a moment and you try G, I'll work it out, and then I'll explain when I come back. Okay, so it's almost done here. Negative b is going to be a positive 8, plus or minus. B squared is positive 64. When I do minus 4ac, I get a negative 80. Since the 4ac was negative and it had a higher absolute value than the b squared, I'm going to get a negative. The discriminant works over here in purple. 64 minus 80 is negative 16. The square root of negative 16 is like the square root of a negative 1 times the square root of 16. The square root of 16 is 4. The square root of the square root of negative 1 is I. So I get 4i out of that. So once it comes out of the radical, I get 8 plus or minus 4i over 4. Almost done. That 4 can divide both of these terms evenly, and I get 2 plus or minus 1i, or just I, all over 1. So 2 plus or minus I is a perfect answer.